So, are there any doubts like from the last blog which I had provided? You might have read any implementation of any of the packages, download errors, anything like that? Kindly turn off your mics in case you don't have any doubt.
నాకేం తెలుసు నా దగ్గర
Okay, so I'm considering that as no doubts. So let's start with today's session. So it will be basically based on implement using the previous pre-processing techniques and some of the pre-implemented models from the libraries and using them for text classification, which was one of the issues which can be addressed by using NLP. So let's start with how we will implement it. So let me give a briefer first, like text classification. As I said, text classification, how we'll do like once you do all the pre-processing, starting with stemming, lemmatizing it, then removing maybe the stop words and stuff like that. And after that, finally, using some encoding like TF-IDF as we had discussed last time, or maybe complex embeddings like word to vec or stuff like that, and then feeding it to a model. Like today, we'll discuss SVMs and naive Bayes. Besides that, you can use complex models like BERT and stuff like that, which are a bit heavy and take a longer time, but generally give better results. So yeah, today I will be talking only about text classification using naive Bayes and SVMs. You can further try doing it using other models as well. Basic models as well, like logistic regression was given as the first assignment. Maybe you can use that as well. So what will we be doing? A text classification problem is like you are given data where you have the different text and the corresponding labels corresponding to how the text is. So using this data, whenever you will be given a new data, you text like you have to label it according to the labels which you are given. So today I will be talking about a binary classification task only. Like you will be having text with either label 1 or 0 sort of, and then you have to classify any new text as to be belonging to label 0 or 1 based on the ML model which you might be using. So main part will be pre-processing only. Model is the one which is inbuilt, just a few hyperparameter tuning maybe, and then we are good to go. So yeah, I will start directly with the implementation. So yes, uh, so the screen is visible, right? Quickly, someone tell me by turning the mic on.
Yes.
Okay. So I have like last time we faced some issues with like NLTK package download issues. So you can directly use this import NLTK download all. So it will download all the packages that there in NLTK and store it. You can also use popular here in place of all. It will download all the popular packages, which are generally the ones which we require. So yes, so that I have already downloaded. Besides that, I have imported all the libraries which might be required in our process, like the tokenizer, the tagger, like one which will be using to tag each and every word, stop words, lemmatizer, encoder. This is the default dictionary which is there already inbuilt in Python. Besides that, WordNet as we had discussed last time, TF-IDF from sklearn, and we'll be using naive and SVM. This two will be running using as an ML models here, and accuracy score, which we'll be using directly to get the accuracy. So let me start. So I have this corpus.csv already loaded here. This is the CSV file containing the data. So I will just do np.random c sorry np.random.csv seed 500. So not always required to write this, but what it ensures that if you run the same notebook multiple times, you will get the same output. Otherwise, it may be the case that it might vary a bit. Like in some case, if you don't write this and run the entire notebook, in one case you might be getting an accuracy of 82.1, maybe in other case you'll be getting 83.5, say, or something like that. So small variations might be there. To avoid that, I'm just writing this. In place of 500, you can write any 100,000, any word, a number which you might like. Just it's setting it to a fixed number. So I will first load this corpus. Corpus is pd dot read csv. This is corpus dot csv. I will read it, and besides that, I also specify the encoding to be Latin 1. So we have the corpus read. So this is how the corpus looks like. We have the text here. We have 10,000 data points as a text and two columns, label 1 or label 2. These are the two labels which are there corresponding to each and every text. So we have to do this type of a problem. Like given any text like this, we will have to assign the correct label corresponding to it. Right. So yes, first of all, in this case, I have taken this from a open source data. So in some of the industrial cases, there might be some of the issues like the row is empty or the label 1 is empty. We don't want such data points while training. So what I will do is I will remove any such rows in which there is any of the text field which is empty. Labels are generally there only because of course it's a label data. So this we use dot drop any, and in place is true. This drops any of the rows which are having a null value corresponding to a text, like an empty text corresponding to a label. Uh, Not necessary if it is the purpose of your problem, but in this case, generally it's preferred. Okay. Then, since we know that writing the letters, this delivery as D capital or D small does not affect the classification of the text, as I know in this case. So I will just convert all of them to lowercase only. So what I will do is uh, say corpus text entry lower or entry. So it just converts each and every word here to lowercase, right? Then what we do, directly tokenize it. So I convert each and every string here into its corresponding tokens, so that only the tokens are stored here. So word underscore tokenize entry or entry in corpus. Yeah. So now if you see corpus, so see here now in the corresponding text field, there is this tokens like words, comma separated words are there only, which were there in the original string, like stunning, even for the non-gamer, stuff like that, right? I will also maybe remove the stop words. Okay, I will remove it later. We were running the for loop. So now let me just specify the tag map, like from noun to like we have that specific in NumPy in NLTK, right? That J refers to adjectives and stuff like that. So just to avoid that confusion, I will set it to this default dict, which we had already imported above, if you might know, lambda wn dot now. So tag underscore map box j is wn dot edj. This means that if we are having the word j, it corresponds to an adjective. Similarly, if we are having the word v, it will correspond to the verb. And if we are having the word say r, right? Yeah, r. So it will correspond to an adverb. So what we will do that whenever the pause tag function of NLTK returns the string corresponding to the tag of that particular word, we will take the first word of that string. If it's J, it's adjective, V verb, R adverb, and by default the fourth one is a noun only, as we have stated here. So we have the corresponding list of the tags as well, right? So if this is the tag map, and so we will set the lematizer. Uh, we had wordnet lematizer. So this will be our lematizer, which we'll be using. So now we have all the tools ready. So now what we will do is that we will just iterate through all the fields which are there in this text column, check for every word and convert this word to its corresponding lemmatized word. Like for stunning, it will be stun. And also remove the stop words like the and this. And also remove this sort of stuff like semicolon is there, exclamation mark is there. We want only the words which are English words, like it can be said like alphanumeric. So we can use Python's dot is alpha function, which tells that whether a word is alphanumeric or not, right? So what we'll do is that for index comma entry in corpus box text. So we are iterating through all the rows of this corpus box text column, right? Uh, we'll have the final list. Final list is the list of words corresponding to each and every row. We will iterate through the complete list. So for word comma tag. So if you might not have seen, yes. Okay. For word comma tag in corpus box. Sorry, corpus. So we can do this. So what I did is like for every entry, this is the entry, right? So if we see, this is the entry and this is the index. So we are iterating through such all indexes and this entry. So what I do is I do pose underscore tag of entry. So it returns to me a list of the word corresponding to its post tag. So for example, there is stunning. So it will return to me stunning, comma, adjective. So JJ, right? I will print and show it to you. So don't worry. So maybe we say continue. I will show it to you by printing only and then maybe continue. So not continue. I will just show you one iteration only and maybe then you can understand. Just oh sorry. So I will show you only the first and what are this. So you can see, like, since I have broken here, so it will run for only one row. So it's printing only one row. So this is the index and this is the entry. Stunning even for the, this is the list of the words which were there, right? Uh, if I print here, print word comma tag. So you'll be able to see here that, so stunning corresponding to its post tag, even corresponding to its post tag. This is what is returned by pose underscore tag of entry. A uh, list of like words, comma, post tag. That is what it's written, right? So you understood how the for loop is working. So let's remove this break statement and this continuous statement. So what we will do is that now we have this stunning VBG and all of this. So we'll take the first words like V, R, J, J, D, N, and so we have this map correspond, so and map it to the corresponding, like it's an adjective or a verb or whatever it is. So if we check for all the words, if it is mainly for, is alpha, we will check whether it's alphanumeric or not, and we will also check whether in stop words dot words box. So what are we doing is that we are checking whether a word is alphanumeric or not. And along with that, we are also checking whether a word is not a stop word, because we don't have to include the stop words while generating the encodings while training, right? So we will append to this final list all such words which are there. So list, maybe we have word underscore lemmatized is word underscore lemmatizer dot lemmatize of word comma pause equals to tag underscore map tag underscore map of tag. So what I have done is, like, we are taking tag box 0, which is the first word, like in VBG it's V, in JJ it's J, and correspondingly we are giving WN dot adjective, verb, adverb, or default noun to it, and hence we have our lemmatized word, and then we just append it to this final list. Dot append word underscore. And for each and every row, we add a separate column, corpus dot lock, sorry, dot lock box index, comma final text is string final underscore. Sorry. What happened? All underscore tag of entry. Hmm. Where did I made a mistake? Oh, sorry. This should be this bracket. No spelling. Yeah. So the training has begun. Not training, sorry, but the pre-processing has begun. So what will be the output is that in this corpus uh, data frame, we will be also adding a third column by the name of final underscore text, which will be containing the list of all the lemmatized words. So that is what this all for loop is doing. So it will take 2 or 3 minutes to run. So till then, do you have any questions up to now? Any questions? No questions?
Can you please explain tag map tag 0?
Yeah. So what actually this lemmatizer, it takes as input this pause. Like if you avoid this, it will not take the position of speech into part of speech into consideration, right? So I am specifying this field part of speech, and it takes as an input like this sort of a format: wordnet dot adjective, wordnet dot verb, wordnet dot adverb, or wordnet dot noun. So what I am doing, and our pause tag function of NLTK returns just a string, which is either JJ or VBG or something like that. So I just mapped it. So for mapping, what I did is that from the string which this pause tag entry returns, I take its first word, that is tag box 0. So for example, it was stunning. Stunning, yeah, stunning. I have to see the context in what it was used. But for example, beautiful. Beautiful is a adjective. So it would have returned JJ, right? So I took the first word and tag map box J, and J I mapped to WN dot adjective, which this POS field takes as this type of the entries are taken by POS as an input. So I just specified that accordingly. So got it. Or
Yeah, thank you.
okay. Then so you can see the corpus. So yes, we have this final text column. Stunning, stun, even, for and the stop word, so they are removed. Non-gamer, alphanumeric dashes there, maybe that's why it's removed. So yeah, this all it has done pre-process. So now we have this pre-process list corresponding to each and every text. So now what we'll do is that we will generate the embeddings and then give it to the MN model, and it will give us the out. So since we have to do the training and the testing, so I don't have any separate test data for it. So I will just divide this whole train data into say 70 to 30 ratio. 70% of the training data and 30% of the test data, which sometimes can be used as a validation data as well, if you know the difference between the two. So yes, train underscore x comma uh, test underscore x comma train underscore y comma test underscore is model dot selection dot so yeah, train test split. So what I am splitting is uh, corpus box final text is what I'm splitting. I want the test size to be point. Model dot selection. Sorry, model underscore. Not enough values to unpack. Sorry. Label specific. Corpus box label. Right. Yeah. So now we are having our train X. Train X is all such texts are 70% of the text of this dataset. Test X are the rest of the 30% as specified by the test size here. And train Y and test Y will be the corresponding labels to the train X and the test X. This is directly done using a function model selection, which we have imported here from sklearn. Right. So yes. So after this, we will just convert it to an using an encoder and then feed it. Encoder equals what we have used, label encoder is used. Yes. Label encoder, then train Y equals encoder dot fit and transform. Oh, we have used train Y. Right, and similarly, I guess for train X as well. Yes. Not test underscore Y. Yeah, so this is the standard procedure which is followed, like converting it to a encoder, like passing it through an encoder, label encoder, so that we have complete representation like we want. Like if I print train underscore Y box 0, not sorry. Yeah. So these are all the 7,000 labels which we are having, and we have converted into an object type. And so now we will directly using TF-IDF on it. So why I did this? Because TF-IDF has this requirement. So TF-IDF, TF-IDF underscore vector maybe is equals to TF-IDF vectorizer of maximum features is the argument which it takes. It's 5,000 maybe, or say 1,000. Then TF-IDF underscore vec dot fit corpus box final text. Yes, so we have 1,000 featured TF-IDF, right? So we will now get the TF-IDF embeddings corresponding to each and every one of them of train and the text one. TF-IDF. For the train X, I will do TF-IDF and vec dot transform string x, and similarly for test x as well. Df. So we have this df converted embedding. So now we will just directly, so naive base, I will just import, like I have this model from sklearn directly. So I will dot, so this is one of the basic normal implementations of naive base only. So what I will do is that I will fit the training data on it. So the training data is trainx, uh, sorry, uh, underscore df. So this one and the labels train one. Yes. So we fit this. We predict is nv dot predict on testx idf print accuracy score of predictions, which is grade nb comma test y, which we were having. Sorry, some error. Should not be. Let me think error. Oh, sorry, I fit it on the wrong. I'm predicting on. Sorry, test x idf, it was right. So this should be trained. Right. This was correct. Is hmm. There's some errors very here. Uh, I guess this meeting is ending, so I will share another link in the group. Please join that. Till that, maybe I will get the error in this. Just a second. Yeah, so I had made a mistake above while writing X and Y. Because of that, the training went a bit wrong. So I will just update and share the screen. While it's running, maybe I will write the code for SVM as well. Maybe let's let it just run and then maybe we can start with SVM. Yes, so we got finally the accuracy as 83.26, which is the correct one, which I made a mistake earlier while writing. So yes, and besides that, so let me quickly code up for SVM as well. So SVM also we will be directly using the SVM which we are having dot SVC. That is for those who know SVM, there is a parameter C which you can hypertune in SVMs. We'll use a linear kernel for it, and say degree is 3. There is another this parameter, and the gamma function will be auto. Sorry, we'll see. And so now directly we can fit svm dot fit the training data to this, the test one, the train one. And after that, we'll just spread and then so svm is svm dot. Yes, now we have fit our data on the training data, and now we can get the predictions using predict of the. Oh, yes, so we get an accuracy score of 84.6 using the SVM, and using neighbor Bayes 83.26, which is generally good for a model which you take directly, like a lightweight models like naive Bayes and SVM, which you take directly from library. Besides that, there may be BERT or some other functions like Alberta or other models which are a bit heavyweight and you can use with a more pre-processing or more specific to your task pre-processing, and then feed them to get the better results. So yes, sorry for that small mistake which I made above, due to which the whole training had to be done again. Yeah. So any questions? No questions? Like, did you understand the flow of whatever we are doing and how are we feeding it to the models? Yeah. . There will be an assignment based on this, and I will be publishing maybe by tonight or maximum by tomorrow. So if you have any questions, please ask me now only so that you might be able to do that assignment well.
By what time will you be posting the recordings and the material?
Recording by today night, maybe 12:30, and assignment, I hope so today, but maximum it can be delayed by tomorrow morning.
Can you like give us the code right away, like on the group?
Like this code, I will give you right away. Maybe yes, I can give it to you right away on the group. Maybe if you have any of the doubts or questions, you may look into it or ask me later. And if you have any other thing, yeah. Yes, I will share this code on the group right away. No problem. Anything besides that? So
Can
I'm
you please
stopped.
explain line
Yeah.
18 again?
18?
Yeah,
Sorry.
line 18 again.
Uh, where can you like bit specific?
The 18th cell actually.
Is that
TF IDF vec. Ha.
TF this one?
Ha.
So yeah, what we are doing is that this encoder just converts the string type of the labels which we are having into the object type. And then what I am doing is that like TF-IDF, it has like it takes only one argument, at least one argument, which is the maximum number of features which are there. Like if you remember TF-IDF, so we take the features and then see compare with the similarity with all the text which we are having. So yeah, this is just one hyperparameter which is there, which you can set it to a good high number. Then what I'm doing is that I'm fitting the what I need the vectors, like the embeddings for this text final column, right? So I'm fitting this text final column into this TF-IDF vector, and whenever then I might have to use it for any of the rows, I just transform that row into this TF-IDF vector sort of. So this train X TF-IDF will be having a list of the list for like it will be having a list of rows. For each and every row, there will be a word embedding or a vector embedding for that text of that particular row. Uh, did you get it, or I can go it again?
No, I got it. Thank you.
Okay. Anything else? Any questions related to the flow or the functions? Like this TF-IDF thing, I know it's a bit non-trivial, but like it's the same code everywhere. Like you don't have to use, like you don't have to change much of the part of this code. So don't worry about that. Mainly you should know how the pre-processing was done and what form of the data is given to the model as an input. These are the two main things, I guess, which you should know for running any model. So yes. And it also depends on the problem which you are trying to solve. If, for example, it's a like cancer data set, like cancer text data set, maybe, for example, or an emotion prediction data set, like if you are given a text, you have to predict the emotion from it, which may be of the type of the label 1, 2, 3, say. So in that case, you will choose some of the specific emotion specific words only from the text, and like you may do some of the tunings in that case if there is some specific problem. Besides that, this is only a general way of how you can solve it, and it will give you an average sort of an accuracy, but to get better results than all, you have to put in some of the extra effort also in this. So, any questions, or should I stop sharing? Okay, I'm stopping the sharing, or maybe I can keep the sharing on for the next 2 minutes or 3 minutes. Until then, you can enter your roll numbers in the chat, maybe for the attendance. Anybody has any doubts? Like, you can tune in these parameters like C, the degree, or maybe use a non-linear kernel here. You can do such changes and check on the accuracies. Sometimes the accuracy gets better. If you might be doing some of the ML search, you might be knowing there is a library called grid search, which helps you to run over all the hyperparameters in a given range and helps you get the best helps you give the best hyperparameters with the best accuracy. So you may also look into that. In Neobase, I have not used any hyperparameter, just use the default model. But in Neobase also there are some of the hyperparameters which you might want to tune sometimes. Yeah. So I'm stopping the sharing. If anybody has any doubts, please go ahead. No doubts? Clear?